Hello everyone, we have this question here coming from the topic called coordinate geometry, and this is additional mathematics. The question reads, in the diagram P, Q and R are vertices of a triangle with, these are the coordinates for P, coordinates for Q, coordinates for R. S is a point on PR such that SQ is perpendicular to PR. So this is the diagram given. The question reads, find the coordinates of S, B, the length of SQ. So now we are looking for these coordinates for S. How do we approach this question? First thing here to do, we need to find the gradients of PR. We need to find the gradients of PR. And we know the coordinates for P it's 0, 2, and for R it's 6, 5. This is the coordinates for P. Then we'll write the formula for gradients. So we know that gradients equals to y2 minus y1 over x2 minus x1. So this will be my x1, this will be my y1, this will be my x2, this will be my y2. So I'll just substitute here. My y2 it's 5 minus my y1 it's 2 over my x2 it's 6, my x1 it's 0. So here I'll have 3 over 6. 5 minus 2 it's 3. Then here I can still simplify further. 3 into 3 it's 1. 3 into 6 it's 2. So this is the gradient for PR. From here we need to find the equation of line PR. So we'll use the coordinates for P. So say P it's 0, 2, and the gradient we have, which is half. So I'll write this formula for calculating the equation, which is y minus y1 equals to m open brackets x minus x1. This is my x1, this is my y1. So y minus my y1 it's 2 equals to my gradient it's 1 over 2 open brackets x minus my x1 it's 0 here. So I'll have y minus 2 equals to half multiplied by x, it will be 1 over 2x, and then half multiplied by 0, it will be 0. Then here we'll have y equals to 1 over 2 x plus 2. Since here 2 it was negative, when it goes to the other side it becomes positive. So this will be the line or the equation for PR. From here again we need to find the equation for SQ. We need to find the equation for SQ. So we need to find also the equation for SQ. But here the question said SQ is perpendicular to RP. So here, since we already know the gradient for PR, we use this formula here. M1 multiplied by M2, this one should be equals to -1. And our M1 gradient is for PR. So here we have 1 over 2 M2 equals to -1. Then we multiply both sides by +2. So here we have just M2 equals to -2. So now we have the gradients for SQ. How do we find now the equation? We use the coordinates for q, which is 3,1. So write this formula for calculating the equation, or for finding the equation, which is y minus y1 equals to m x minus x1 there. This will be my x1, this will be my y1. So here you have y minus 3 equals to, the gradient there, it's 2, open brackets, x minus, here we have 3, so we have y minus 3, minus 1 here, even here it's 1, equals to negative 2 multiplied by x to give us negative 2, x, negative 2 multiplied by negative 3 to give us positive 6. So here you have y minus 1 equals to negative 2x plus 6. So here it will be y equals to negative 2x plus, when this negative 1 goes to the other side, it becomes positive. So 6 plus 1 is 7. So this is the equation for SQ. So now let's find the intersection of this equation PR and the SQ. Since here we know that the equation for PR, it's y equals to 1 over 2x plus 2, and for SQ equation, it's y equals to negative 2x plus 7. So we just equate this equation. So we have it will have, here we have negative 2x plus 7 should be equals to this, which is 1 over 2x plus 2. Then this half will come the other side and 7 go the other side, so we'll have negative 2x minus 1 over 2x equals to 2 minus 7. So here, there we have 1. We'll look for the common denominator here. So here we have 2. 1 into 2, it's 2. 2 multiplied by negative 2x, we'll get negative 4x minus 2 into 2. It's just 1. 1 multiplied by x there to be x like that, equals to 2 minus 7, it will give us negative 5. So from here, we cross multiply, and negative 4x minus x, it will give us negative 5x equals to 2 multiplied by negative 5 there, we'll get negative 10. Divide both sides by 5, by its negative, even there by its negative. So this and this cancels, so we'll have x equals to 2. So from here, we'll just pick this equation so that we find the value for y. I'll get this one for PR. So say my y equals to 1 over 2x plus 2. So where there's x here, I'm going to put this x. So I have y equals to 1 over 2. Here I'll put 2 plus 2. Then this 2 and this 2 cancel. So here we'll have y equals to 1 multiplied by 1 plus 2. Then we have y equals to 3. Then we can conclude and say, therefore, the coordinates, you can say the coordinates for AC, it's 2, 3. So now we have found the coordinates for S here, which is 2, 3. And here now, the second question said, find the length of SQ. Very easy here now to find the length of SQ. So in order for us to find the length of SQ, we know that the coordinates for AC it's 2, 3, and for Q we know that it's 3, 1. So here we just use the distance formula. So we'll say the length equals to open bracket x2 minus x1 squared plus y2 minus y1 squared. So this is my x1, my y1, my x2, my y2. Then here we have my x2, it's 3 minus my x1, which is 2. Then we square plus my y2, it's 3 there, it's 1, my y2 it's 1, then my y1 it's 3 here, then you square it, so you have 3 minus 2 here, we have 1 squared plus 1 minus 3 will get negative 2, then you square it, so here you have roots, then 1 squared it will just give 1 plus negative 2 squared to give us 4, then we add 1 plus 4 will get 5, then this will be our length. So since here there are no units, we can just put units like this, then you are done. This is how you can approach this question. Thank you very much for watching.